Welcome to the new episode. Subscribe to the channel so as not to miss the new episode. More videos on our channel. In the fall of 1977, an unprecedented event occurred that became a worldwide sensation. With a difference of 16 days, two twin NASA probes, called Voyager-1 and Voyager-2, were launched into space. Each of them had to fulfill their mission. Voyager-1 explored Jupiter and Saturn, while Voyager-2 explored Uranus and Neptune. In 1979, Voyager-2 got as close as possible to Jupiter and allowed scientists to obtain indirect evidence of the existence of a liquid ocean under the surface of the Europa satellite. In 1986, the probe flew past Uranus. And in 1809, he passed by Neptune and transmitted to Earth unique images of the surface of his satellite Triton. On December 10, 2018, the device overcame the Heliopause and entered the world of stellar space. Why did he lose contact with the Foundation for almost a year, and what incredible scientific discoveries did he make during this time? See this issue. NASA's Global International Deep Space Communications Network consists of 3 complexes capable of tracking probes in stellar space. It includes the Madrid Deep Space Communications Facility in Spain, U.S. Goldstone Observatory, and the antenna system in Australia, in Canberra. They all consist of huge telescopes with ultra-powerful transmitters and ultra-sensitive receivers. However, there is only one NASA Deep Space Communications facility on Earth capable of communicating with the Voyager-2 satellite that has left the solar system. What is the problem? All interplanetary vehicles are moving near the aircraft, and the clip is in the field of view of all 3 NASA Deep Space Communications observatories. However, Voyager-2 was an exception to this rule. To get closer to Triton, Neptune's largest moon, the probe flew over the North Pole. Because of this maneuver, its trajectory leaned to the south so much that the antennas in the northern hemisphere of the Earth lost contact with him, as he disappeared from their line of sight. Due to the specifics of the limited visibility of the southern starry sky, maintain contact with Voyager-2 in starry space. Scientists could only from the Australian Observatory. Its antenna system contains a 70-meter rotating parabola weighing more than 3,000 tons, consisting of 272 aluminum panels, with a total area of 4,180 square meters. The Deep Space Station was put into operation in 1973. Initially, its diameter was 64 meters. In 1987, before the approach of Voyager-2 to Neptune, it was increased to 70 meters. It is the only antenna capable of tracking Voyager-2 at a distance of 18.8 billion kilometers from the Sun. However, during operation, NASA equipment became obsolete. The number of spaceships has increased, and their mission has become more complex. Therefore, there is a need to repair and upgrade the only antenna that communicates with Voyager-2. On March 4, 2020, NASA announced the start of a scheduled repair of the Australian complex, Deep Space Communication in Canberra, and modernization of the 70-meter antenna of the SSR. In the course of planned technical work, 2 new transmitters operating in the range were installed, the power supply system was improved, the cooling system was put in order, and the electronics were updated. The work was carried out very promptly. Scientists hoped that during this time they would be able to receive signals from Voyager-2 using 3 auxiliary, Australian and Czech DSS fishing antennas. They could provide telemetry reception, but in the event of an emergency, they would not allow mission specialists to put the device into safe mode and fix the problem. In an extreme situation, scientists could only hope that the probe's 40-year-old computer port system could handle the emergency on its own. But something apparently went wrong, and communication with the Voyager-2 spacecraft was interrupted for almost a year. On October 29, 2012, mission operators, during tests of upgraded equipment, sent a zone and a series of commands to the lost in the depths of space. And Voyager-2 accepted this luck and sent it back to Earth. Connection confirmation signal. Already the first data received from the probe became a sensational discovery. Information has appeared that on the border of the heliosphere there is a so-called image of stellar space near the solar bubble. Recall that the space inside the solar system is not an absolutely empty perfect physical vacuum. It contains only stellar matter, plasma, dust, gas, space debris left over from the Big Bang of cosmic microwave background radiation. And the Sun is a source not only of electromagnetic waves, but also of the solar wind. The region of space around the Sun, in which the magnetic field of the Sun and the solar wind propagate, is called the heliosphere and is, roughly speaking, a giant bubble. Behind it is the heliospheric mantle, in which the solar wind slows down, and its movement becomes turbulent. Behind the mantle is the Heliopause. It is believed that it separates the helium sphere from stellar space. The first data about what happens behind the Heliopause was transmitted to Earth only by Voyager. It turned out that the direction of the magnetic fields inside and outside the Heliopause is approximately the same. Prior to this, astrophysicists thought that the magnetic field dominant in the plasma of the stellar medium would be directed in the opposite direction, or its movement would be chaotic. The mission staff then even doubted that Voyager had crossed the border alone. The information was inaccurate, as some of the equipment in the first zone failed in 1980. All hope was on Voyager-2, which has onboard serviceable instruments that measure plasma parameters more accurately. The second probe actually measured the density and accurately determined the temperature of the plasma beyond the Heliopause. It turned out to be equal to 50,000 Kelvin. It was also possible to measure the concentration of protons perturbed by stellar plasma and the magnetic field behind the Heliopause. Now we know exactly what is on the border and beyond the solar system. One of the most interesting discoveries was that the Heliopause is much closer than previously thought by the results of numerical simulations. It was possible to establish that the level of radiation in the stellar medium is 3 to 4 times higher than inside near the solar bubble of the heliosphere. It was also a surprise that the Heliopause has a heterogeneous structure in different regions. Heliosphere of different thickness. This was found out due to the fact that Voyager alone crossed the Heliopause in the northern hemisphere of the heliosphere, and Voyager-2 crossed in the southern hemisphere. Previously, it was believed that not the solar wind penetrates beyond the Heliopause, but interstellar plasma penetrates into the Heliopause. But Voyager-2 discovered that there are holes on the boundary between the southern heliosphere and the interstellar medium through which plasma bubbles of the solar system seep into outer space. Matter? Apparently, there is some principle of cosmic magnetism unknown to us so far, which controls the behavior of magnetic fields in space. This is proved by holes in the bubble of the solar system and the direction of magnetic fields at the boundary of the heliosphere and the interstellar medium. We continue to follow the journey of space vehicles and will acquaint you with new information. Subscribe to our channel so as not to miss the discovery of Voyagers, which may soon turn our ideas about space. Be sure to like this video and write how do you like the video? More videos on our channel. Do not miss.